our wonderful panelists, we have Emily Crose, who describes herself as a threat hunter. She's a security researcher and professional with 10 years of experience, 7 of those in the CIA and NSA. She works for a DC startup and is directing the Nemesis project in her free time. We have Inez Montani, founder of Explosion AI from Berlin, Germany. She specializes in developing applications for AI and natural language processing. She's a core developer of Spacey and Prodigy, and she's a late addition to the panel, so thank you for joining us. And Vicente Ordonez is an assistant professor in the Department of Computer Science at UVA, researches the intersection of computer vision, natural language processing, and machine learning. He's a recipient of the IBM Faculty Award and Google Faculty Research Award, PhD from UNC Chapel Hill, and he was a visiting researcher at the Allen Institute for Artificial Intelligence before. So, some questions. Let's start with Emily. So, tell us briefly about your Nazi image identification project for people that weren't in your talk earlier, and the Nemesis project, and just tell us a little bit more about what you're doing with that.
Sure. So my project is called Nemesis. It's been a side project. As I said in my talk, I'm not really a data science person. I'm more of an amateur hobbyist. But the project is meant to look through arbitrary images and find examples of Nazi symbolism. You could adapt this to social networks, scanning through images to try and find them, identify them, and then do things with them. There's lots of different things you could do with them. So that's, in brief, what that is.
Okay, and Inez, tell us a little bit more about Spacey and Prodigy. What do they do?
Thanks. Yeah, okay. So Spacey is a popular open source library in Python for natural language processing. So the idea is if you have lots of text and you want to find out more about it, from grammar to finding phrases and concepts, you can use the library, you can train your own models on your data. And Prodigy is a new tool we're publishing, or we've released, which helps with actually creating very topic-specific training data more easily by using modern insights of user experience and actually, allowing data scientists to really iterate on their data as well as their code and work very closely with what they're doing.
Vicente, tell us an example of a recent research project that you've done and some of the key findings.
Well, I think you did a good job summarizing some of that. Yes, I work mostly on computer vision, so recognizing objects from images, and in this discovery process, we were interested just in improving the accuracy, just as everybody else. I mean, having a better recognition algorithm that can detect things at a higher rate of accuracy. But at some point, we realized these algorithms were making mistakes for different kinds of images, and at some point, we decided to look at images that had women and men separately, and then we realized, things were not working quite the same rate for both cases. Yes.
So if each of you could answer, and we can start with Vicente, what's an example of social bias in machine learning that you've seen in your own work? You kind of went over it a little bit, but go a little bit more in depth about the social bias.
Right. So one thing you mentioned was, for instance, pictures of cooking. This is a task that, should in principle be independent of who is in the picture, right? Because a kitchen is an object that exists independent of whether even there are people there or who are the people there. Yet the algorithm seems to be relying on some of these cues from the people to make the determination whether this is a kitchen or not, or the other way around. If it's a kitchen and it's confident there is a kitchen, and then uses some of that information spills out to determine the gender of the person in the place. So, and we found these even for other scenarios where you might think of as more innocent. For instance, umbrellas. Detecting umbrellas. Somehow the algorithm makes more false positives when there are women in the picture, and it's about detecting umbrellas, for instance.
How about Emily? Have you noticed any social biases in your work?
Yeah, definitely. Mine finds Nazis, and only Nazis, hopefully. So yes, it's a built-in bias. I chose this bias, and whether it's a good bias or not, I think is for the audience to determine. But yes, it's a bias. Everything I built was bias here.
Yeah. Yeah, so in our case, what's kind of interesting about natural language processing is, okay, if you want to train a base model that just recognizes the grammar in a sentence, part of speech tags, named entities, you do need a lot of data, and you need a corpus. And normally, these corpora are available, and they're produced by academia, which is very nice, and everyone uses these corpora. But one very important consideration here is to actually think about, okay, who funded this and where does this come from? And we're used to universities being very free and independent, even though they are government funded. But there are other cases like, okay, we have one corpus for Chinese that we can use. Where does this come from? Who funded this? And when we're training, as like non-Chinese speakers, we're training a model, even if it just predicts syntax and person names and texts. What else is encoded in this data? How was this data selected if it was sponsored by the Chinese government? So these are very important questions that are not, we try to address by saying, try to collect your own data if possible. Don't, we have to move away from just relying on whatever set is available without questioning where it comes from, and instead really do our own thing.
So out of all the things that I covered in my talk, what is something that you think you want the audience to definitely take away? What tools or techniques do you think that people should be focusing on learning right
All
now?
right. Well, as I mentioned before, I think sometimes this over-reliance on accuracy for its own sake. I think people focus a lot on the data, and then you look at the data. Is it biased? Is it not biased? Is the bias very strong? And then you forget about looking at what the model is actually learning afterwards. People have generally this assumption that your model is as good as your data is, but it could actually be much worse. In terms of accuracy, it could be as good as the data you train on, but in terms of other variables you don't control for, then you don't know what could be happening. So these machine learning models sometimes are taking these shortcuts that sometimes people seem to take, these rules of thumb to make decisions as opposed to, based on evidence, make any kind of decision. So I think thinking this from the start, thinking about what are the metrics that you're going to design, what is the data that you're going to use, these are all the things you have to take into account, not just pure accuracy, I think.
One of your papers was about removing some of the bias. So can you talk a little bit about that? What are some of the approaches?
Right. So one of the papers was about removing bias, and the thing we did was when you want to make predictions at test time, you can make predictions collectively as opposed to individually. So instead of looking at a single sample to make a prediction, you can look at a collection of samples and make predictions at the same time. So that way you can balance what is the quota you're going to allow for the predictions that you're going to make for different segments of the population. And this quota is not something we, for instance, decided, this group of people deserve this much, this group of people deserve this much. We also try to follow the data distribution. We looked at how is the data distributed, the data that we use for training, and we're trying to make our algorithm to behave at least as good as the data it's trained on. And, I think maybe we need to go beyond that. Yes.
And anyone else have suggestions of things that the audience should be taking away and learning?
What I find very interesting is also you mentioned, of course, making the decisions transparent to the end user who's presented with the result of a model. But I think actually probably, so that's very relevant. And I think it starts even earlier to make the whole process transparent to the developer. Because we often talk about these technologies with this assumption that, everything works and everything is great. And, we can do we've done all the hard part. And now we're moving on to the even harder part. Look, self-driving cars. But actually, the reality is most of the stuff does not work, and even developers are kind of shooting in the dark. And I think when it all comes down to the tooling, it's easier to produce these things now, but it also means that it doesn't necessarily mean that people know what they're doing. And so I think a first step, the developers are actually able to really become aware of, okay, why is my model doing this? What is my model even learning? How can I change what my model is learning without just collecting new data and trying again? I think that's the first step we need. And then we can move on to say, okay, now we present this to the end users. But I think,
And that's actually something that I've found in my own work, and it was a bullet I kind of breezed by there, but involving subject matter experts from the beginning to the end. So if you're going into an area and building a model about something you might not be an expert about, making sure you understand how the data was collected, what might be in there that you were not aware of, the actual definitions of the different fields, maybe the field names aren't named exactly clearly, and knowing what the results of your model mean. You're right, like the developer knowing those things and being aware is just as important as communicating that to the end user. So we're going to take some audience Q&A, and we have some runners that are going to take the mics up. So if you just raise your hand, I'll try to see, and we'll get some audience questions for our panel.
Yeah, that's an interesting discussion. One thing about, let's say, bias in data sets, I think there was a paper called Gender Shades or something like that, where they found that gender classifiers perform worse on female people with dark skin because the subset of people with dark skin was smaller than the subset of people with a lighter skin. And that is something maybe easy to fix in terms of just adjusting the imbalanced data set problem. But for example, other problems where you have, let's say, that was one in all your slides, the black box model. I think, what do you think about black box models? Because I think that is maybe also not really an issue, because if your model is fully differentiable, you can look at the gradients, go back and see if you, for example, in a credit score example, can say, okay, if your mortgage is, or if some variable is higher by $5,000, then you would get this credit score down by, or up by so many percent. So I think black box models are not really a problem, but in certain cases, I think it can. How do you think, in general, my question would be about interpretable models versus, let's say, these deep learning neural network models?
Okay, yes, gender shades, I believe that's by one of my computer vision colleagues, Timit Jabru at Microsoft Research. So yes, I don't think, first, I don't think it's so easy to balance things sometimes. If you're just making binary predictions, perhaps you can balance the data set, but in some of the examples we had, for instance, in our work, where we were making structured predictions, where the decision is not just binary, but we were detecting various objects in the image, then it's not easy to balance, because you could account for one variable and you could say, well, we're going to have 50-50 of maybe gender or some other variable that you care about. But then what about the other variables? I mean, the number of umbrellas. I mean, how do you make those balance? And then how do you make those balance across the other variables? I mean, it's really hard to control. And there are a lot of objects in the background, all of the images, that are not annotated, but they're also being fed into these models. And then you cannot balance those. I mean, it's really difficult, actually, to balance. I mean, in the binary case, the most simple example, you could balance, but then how do you make sure that, you know, people are wearing glasses at the same rate, or people are wearing the same makeup at the same rate? I mean, or all of these other things you cannot control for. I mean, it's hard to balance those because some of these are by definition unbalanced. So, and then the second part of your question was about, I think I already forgot. Yes, the black box models. How do you? Well, I think you should still try to make sure that at least you're looking at the distribution of your input. Even if it doesn't have labels, I mean, you can always look at a statistical distribution of your input, and you can look at the statistical distribution of your output, and make sure that those are, at least as a sanity check, are following the same trends once you train your model, even if it's black box.
And one thing I mentioned in the presentation is that there are new packages that are coming out that actually can kind of reverse engineer the models a little bit. So one example was Lime. And what you do is, after the predictions are made, you can run this using the same input value, and it looks at the predictions and it tries to figure out which inputs were most related to the prediction after the fact. So you might take a black box model and run this afterwards and see if you can kind of suss some of that stuff out. So for example, I did a model that was predicting whether or not somebody would get admitted to a university. So I ran Lime on it afterwards, and it was able to show me which of the input variables seemed to be more useful for each sample, for each person, which of the input variables seem to put them over the edge of being admitted or not. I love the example that they use online when they talk about Lime. I think it's on the package documentation. There was a model that was supposedly able to determine the difference between a wolf and a dog. And so it was saying, oh, this model is awesome. It's like 80% correct at separating wolves and dogs. Well, that seems kind of unbelievable, right? Because they look the same. And so after the fact, what it turned out is Lime was able to identify which parts of the photo were being used to train it, and it was the snow in the background. So the photos that had snow were labeled as wolves. So it was able to identify what part of the photo was actually being used to make that classification. Okay, do you have a question?
Thank you. Sorry. Thanks for the discussion. I'll just make, if you don't mind, I'm going to make kind of a comment too. I'm the author of that book that was flashed on the screen. So I'll just throw out that like black box algorithms should be thought of as like processes, like any other process. Like usually they're human processes. We don't understand human processes deeply either, but like we can think of like the hiring algorithm or the hiring process, which we've always wondered, is that fair, right? And so we can think about how the orchestra audition, they became like a blind audition in order to improve like fairness, because they were like, oh, we're nepotistic and we're also sexist or whatever. And it worked because they decided what qualification they actually cared about, and they also blinded themselves to everything else, right? So the reason I mentioned that, it's kind of a big setup, but the point is that like we're never going to be able to simplify any kind of fairness question around AI, because we're always going to have to get to that question. We're not going to be able to avoid it. Like we think AI is going to help us bypass these hard questions, but at the end of the day, if we're going to decide whether a process is fair, we're going to have to say, what do we mean by qualified? What do we mean by qualified? And until we answer that question, which everyone's trying to avoid, we're not going to be able to decide whether something's fair, because at the end of the day, we're going to be like, are women and men who are qualified getting through this process at equal rates? It's not just going to be a question of like how many women applied versus men applied, because there's always going to be someone saying, yeah, but how many qualified women applied? You know, so you're going to have to get there. And in some sense, like there will be no AI solution to this problem. This is always going to be a human question and a human solution.
All right, another audience question?
Hi. So thank you for that last comment. I certainly agree. I just had a quick question, I guess, related to bias in models and kind of debiasing models. It sounds like there are kind of like two approaches. One is to do it kind of like hard, and I'm speaking in this related to kind of like a word debuck model, say. One approach is to kind of do like a hard or soft debiasing, where you're kind of like moving the words so that the cosine similarity between woman and programmer is the same as man and programmer, right? The second seems to be a kind of debiasing in production. So you're saying like the language is inherently biased. How do I productionize, when I put this model in production, how do I create a system that isn't going to output biased results? And I guess my question is, if you have experience with either one of those, which approaches have you taken, and why have you taken that approach? And my second question is, I use Spacey a lot. It's a really wonderful platform. Do you have any initiatives to kind of include something like concept number botch or some other kind of like pre-debiased model when we talk about kind of like debiasing word embeddings?
So, I mean, from the Spacey perspective, of course, we see it as, okay, what we want to provide to the user is a base model trained on a very general purpose corpus, even though there are also problems with this, as I mentioned before, that then users can build upon. So the idea is ideally, of course, we would strive towards like a solution where the base models that know syntax and a basic knowledge of the world don't include or include as little as possible about this. But even, mentioning the word vectors, of course, that's a problem. But we definitely approach this more from a perspective of giving the developer more tools so they can adjust the models for their very specific use case. Because I think there's another problem with bias, that if you approach it from the perspective of how can we provide general purpose debiased models that then users can use and say, hey, great, my model is not biased, officially unbiased, certified. That's the other problem. So I think, we don't want to make these claims. It's more like we believe that, okay, you as a developer, you should work as closely as possible with your data. And also we really trying to get the message across that pre-trained models are great to quickly test your ideas, but they're not, what you should use and call it a day. Like they're an idea, there's something you can build upon, but you should be training your own models, and you should really start much lower on the scale. Yeah, I feel like maybe I don't have a perfect answer for you here, but really, I mean, that's, I would definitely see Spacey. Spacey is a developer tool and not, a component you just put in your pipeline that takes care of all NLP questions for you.
And I would like to add to that too. That I think there is kind of an inclination to offload a lot of the human decision making to computers, especially in this case, right? It's it's very easy to say the artificial intelligence is good. So if you build a model that is supposed to be general purpose, then you kind of have the same effect, right? It ends up being the same type of the model is debiased, so it's all good, right? Not necessarily. There's lots of other things that could sneak in. And as Renne was saying earlier, there's lots of different places where it sneaks in too. So the pre-trained model is only one aspect of that.
Yeah, and also maybe just to quickly reiterate my point from earlier, it's not like everything just works. A lot of stuff doesn't work. And also one takeaway we can, get from looking at a biased output where, for example, black faces are not recognized. Yeah, it could mean that, our training data was shit and we should have actually trained on more black people. It could have just been okay, our system is bad. Our system can draw conclusions from hair colors and maybe accessories or facial hair in different colors, but actually it can't really recognize faces at all. It just sucks. It's bad. And that's something that often gets lost in this discussion, that often our systems are just bad in general.
So I think we need to wrap up now. So if there's any final advice you want to give the audience, if each of you wants to say any last thing to wrap up.
Yeah, sure.
Sorry, I'm the last one.
Time for questions. Is it very quick?
Yeah, absolutely quick. Chanel Brown, Virginia State University. I just wanted to ask if you believed, or did you find within your research that trends or fads or any type of new thing that the millennials, I guess, have compared in these data had influenced biased outputs within AI, or do you feel it's just a programming error? Could it be influenced by trends?
Yeah, so one of the concerns that I've also heard about these biases is that the data that is used to train these models is historical by definition, right? So it's been collected before. So how far back do you want to go so that it reflects the reality of the present? So that's something you should also be aware of. Because, yes, cultural trends, if you collect data for the past year, it's going to train a very different model than if you use data that was collected since the 60s. And then you have to question whether that's even ethical to do, based on maybe troubled history, and use this data to train your model. I think that's problematic, definitely problematic.
So one-liner wrap up for each of you. Very quick.
Well, I would like to say, design your machine learning algorithms with the user in mind. User variables are not like any other variable. They should be perhaps treated specially, and not just it is something you have to control for. So that's my final thought.
I would say definitely the same. And also keep in mind that what you're designing today could very well live on for 50 plus years. And what I usually say to people when this topic comes up is, imagine if we had NLP working that was designed in the 60s. Doesn't sound great to me.
Yeah, and I think the best advice I can give, collect your own data. Don't let anyone lock you in. Work closely with your data. Do your own, tweak your own models. And anyone who promises to give you a solution that will just work for anything is selling snake oil, because that's not what's happening.
Thank you, panelists, for a very interesting discussion. That's all we've got.